Welcome to Mr. Grant's video series on Algebra 1. This is going to be your first lesson. Your paper may even say something like Lesson 1.1. And it might even have a different day, a different lesson title, and as the years change these lessons, I'll rearrange these videos on YouTube, but they should still be relevant. Today we are going to refresh your memory on how to solve one- and two-step equations. You actually learned how to solve one-step equations in 6th grade, two-step equations in 7th grade. However, it's been a weird couple years with COVID. You may have forgotten, you may have not gotten it the first time, so we're going to go back through this. I am going to do a couple strange things today, and it's probably going to be for today only, but I'll explain why as we get there. I'm actually skipping this first page though, as that's pretty relative to my class, and we're going to jump into the math part on this second page. There are going to be a few parts where I ask you to pause this video and work them out on your own. You don't just want to sit here and copy down the work as I do it. Well, maybe you do, but that's not a good idea to do, because then your brain isn't thinking, you're just blindly copying. You need to try this first in order for your brain to make those connections. You need to try and succeed, or even better, try and fail, so that you can make new connections in your brain so you can succeed next time. This first part is going to have you check to see if the given value, and our given values here are written like so. You might notice that each of these given values is written in a set of these sideways curly braces. I kind of call them sideways seagulls. When you draw your seagull, right, something like that. That's what they are, just drawn sideways. A lot of times you'll see answers, especially in Algebra 1 and higher up classes, give answers in these curly braces. And we do that just to show you if there's more than one answer, right? Let's say that there were two answers at once, like 30 and 31. We do that to show you those are two different answers, and maybe not like a point on a coordinate plane or something else weird. So we're going to practice that curly brace, or recognizing that curly brace notation. What we've done here is given you each of the answers to the equation, and your goal is to basically prove it. How do you know that that's an answer? Well, hopefully you have checked or proved answers before. All you really need to do is take your answer, which says that the variable n is going to take on the value of 2, and you need to replace both of the n's, or if there's more than that, all of them, with the value of 2. Don't forget, when you substitute a value in, you always want to replace that variable with parentheses. The parentheses are going to help you keep your operation straight. And then, of course, to prove if something is a solution or not, you want to simplify each side of the equal sign, right? You've probably seen before that the equal sign separates an equation into two parts. We have the left side and the right side. We're just going to simplify each side. Well, to simplify a side, we have to think, well, do we do 2 minus 3 first, or 4 times 2 first? You might be thinking, oh, I did remember how to do that in the past, right? That's just PEMDAS. And I like to write PEMDAS like this, where we start with what's in the parentheses, but 2 is in the parentheses, and there's nothing to do to 2 in the parentheses, so we're done with P. E is an exponent. Those are those tiny numbers like a square. There is no exponent here, so we're done with that. We're on to multiplication and division. So we do both of them at the same time as we move from left to right. I see a 4 times 2 here, which gives us 8. And I see a negative 2 times 2, which gives us negative 4. Done with multiplication and division, on to addition and subtraction. 8 minus 3 is 5. Negative 4 plus 9 could be tricky. I rearrange it. 9 minus 4, and that's also 5. Because the left side is equal to the right, n equals 2 is a solution. I did all this without a calculator, and I think the next two are very doable without a calculator as well. If you need one, you can use that to support you, but you really should strive to do this without a calculator. So pause the video here, try B and C. You can unpause it to see my work in just a bit. Alright, hopefully you tried B and C. If you want to see if you got this right, don't watch me do the whole thing unless you have a couple extra minutes to spare. Just skip the video forward, maybe play it at 2 times speed, just to make sure everything looks good. So I'm going to substitute this in. I see 10/3 is a fraction and 9 is not a fraction. So I'm going to write 10 in line with 9 and put this over 3 here. That will help us in the long run. And then same thing here, 3 10/3 plus 1. Now, you might remember that in order to multiply fractions, we want to make sure both numbers are fractions, so you could put this 9 over 1. It's not a bad thing to do. I could do this with 3 over 1 as well, and you'll notice that I closed my parenthesis in the wrong spot. There we go. Now, when you multiply fractions, you multiply straight across. But I would suggest not doing that here, not yet, because we also might remember that when we are multiplying fractions, you can cross-reduce, which means 9 and 3 have a common factor. We can divide out 3. 9 divided by 3 is 3. 3 divided by 3 is 1. So really I have the fraction 3 over 1 times 10 over 1, and now I'll multiply straight across. 3 times 10 is 30 over 1 minus 19. Same thing here, 3 divided by 3 is 1, 3 divided by 3 is 1, 10 times 1 is 10, 1 times 1 is 1. In fact, we also should remember that if you have a number over 1, we really don't need to keep that as a fraction anymore. So what do we have here? 30 minus 19, I think that's 11. 10 plus 1 is also 11. Great! 10/3 worked. Woo! We're doing super well. Let's try our last one. Last one, we know that y is 30. So we go through and we replace all the y's with 30. And notice I did do an extra set of parentheses there. We'll talk about if you have to do that or not, but it's never a bad habit to use parentheses. Well, we follow PEMDAS. PEMDAS, to simplify just this left side, I'll just do the left side first, we'll come back to the right, says do what's inside the parentheses first. I don't see anything in the 30, but I do see something inside these parentheses. I see a 30 in parentheses plus 8. But if 30 is in parentheses and nothing is multiplying or dividing to it, we can actually drop those parentheses and just think of it as 30 plus 8, which is, of course, 38. Notice, though, that I kept the parentheses around it so we can see the 38's multiplying times 3. On the right, no, I said I'd just do one side at a time. 3 times 38, 3 times 8 is 24. We're carrying a 2. 3 times 3 is 9, plus 2 more is 114. All right, let's try the other side. 2 times 30 is 60. 60 minus 6 is, 54. Those, to me, do not look to be the same. To show that two things aren't the same, we put the equal sign with a little slash running through, and we would say that y is not equal to 30. If it makes you happy, you could say a little sad face. All right, so let's try to connect everything we're going to do today. When we simplified each side of the equation, and we might remember that each side of an equation is called an expression, right? An expression would be 3 times y plus 8. Another expression would be 2y minus 6. Expressions do not have an equal sign. When you put an equal sign in between two expressions, then it is known as an equation. So when we simplified this side of the expression, we used PEMDAS to know what to simplify first. When you're only working with an expression, or one side of the equal sign, you're using what we call properties of expressions to simplify that side. PEMDAS uses properties of expressions, distributing, combining like terms, all properties of expressions. But we're in algebra now, and algebra isn't about simplifying one side of an equation. It is about moving terms from one side of the equal sign to the other. So we need what are called properties of equations. You've probably seen these before. We have 4 properties of equations we're going to cover: the addition property, subtraction, multiplication, and division. And in fact, we're going to use the same equation every single time. We're going to use the equation 2x plus 6 equals 12. So what's going to be even more weird, even stranger, is we're not actually going to solve this equation. We're just going to show what these properties mean. Because sometimes on tests, they'll say, which one of these is an example of the addition property of equality? And we don't want that fancy phrase to mess you up when it's a pretty easy concept. So here we go. I'm going to start with the expression 2x plus 6 equals 12. Now, I did mention that we're going to use one other weird method today, and I'll explain why shortly. We're going to use the horizontal method of solving equations, or properties of equations, for today. Tomorrow you get to get rid of that. Even by the end of the today you do. But what is the horizontal method? You probably haven't seen this before. Well, I like the horizontal method because it lets you do the same thing every time. And here's how it's going to work. 2x plus 6 equals 12. We're doing the addition property of equality. Now, to use the horizontal method, we always want to give some extra space at the end of the first expression and the equal sign. So I'm given some extra space, even a little bit more than that, and then 12. So there's extra space on the right here, and there's extra space on the right here. Now the addition property of equality tells us that we are able to add any number we want to both sides of the equation. Seriously, any number. So I'm just going to pull a number out of the hat, and I'm going to say I want to add the number 10. So I'll just remind you, up here we're doing adding 10. Well, how do we do that? Whenever you use an algebraic property of equality, these four, I always, always, always want you to group each side of the equation in parentheses. Always. And then we're going to add 10. Now the nice part with addition and subtraction is once you add something to both sides, you can actually drop the parentheses. And you're like, this is kind of silly. Why are we doing parentheses? Well, you will see in just a second. So we're going to add 10 to each side, and then we're promptly going to drop those parentheses. 2x plus 10 equals 12 plus 10. And then we're going to simplify. 2x, 6 and 10 is 16, equals 12 plus 10, which is 22. Now what did we do here? Well, of course, we added 10 to both sides. What we did, though, is we rewrote the equation in a way that whatever the answer is to 2x plus 6 equals 12, the answer is still the same down here. Algebra is all about keeping the answer the same, but making the equation look different. I chose to add 10 to both sides. Why? Because I picked the number 10. You could have added a million if you wanted. Let's look at one more. Here's the subtraction property of equality. And again, we're going to do the same thing. So I'm going to do 2x plus 6 and leave a gap, 12 and leave a gap. This time, instead of adding 10, since we're subtracting, let's subtract 7. Again, I'm just picking these numbers, doesn't matter. Well, we're going to group each side, and we are going to subtract 7 with each side. Now again, the nice part with addition and subtraction is once you put these in parentheses, you can instantly drop those parentheses. And you're probably thinking, well, this is such a silly step. Why am I doing this? There is reasoning behind my madness, I promise. Let's simplify. 6 minus 7, negative 1. 12 minus 7, 5. What did we do? Well, we said whatever the answer to 2x plus 6 equals 12 is, will be the same answer to 2x minus 1 equals 5. In case you're curious, the answer is 3. Right? If you substitute 3 in here, 2 times 3 is 6. 6 plus 6 more is 12. If you substitute 3 in here, 2 times 3 is 6. 6 minus 1 is 5. 5 equals 5. All right, let's move on. Multiplication property of equality. Now, I'll give you a couple different ways to do this. Some people don't like this method that I'm using, this horizontal method, but you'll have seen this next one. So, we have 2x plus 6 equals 12. And sorry, I need a little bit more space. There we go. And this time we need to multiply. Since we're multiplying, the numbers are going to get big. Let's pick some smaller numbers. Let's multiply by 3. Same step as before. We group each side, and then I'm going to do a times 3. All right, well, as I go through here, the right side's pretty easy. 3 times 12, we know our multiplication tables, that's 36. The left side is a little trickier. You might not have seen this for a while. When you are multiplying a side that has addition or subtraction, you need to take this 3 and multiply it to every number on the inside. This is called distributing the 3. So 3 times 2x will get me 6x. 3 times 6 will get me 18. Now, you might not like seeing it that way. You might say, well, whoa, 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 whoa. My teacher didn't show it to me that way. My teacher said we have 2x plus 6, and we have 12. And my teacher always put the times 3 out front on the left side. Is that okay? Of course that's okay. There's nothing wrong with that. This is switching terms around here. This is called our commutative property. We're allowed to multiply at the beginning or at the end in this case. 3 times 2x is 6x, 3 times 6 is 18, 3 times 12, 36. It's the same thing. I just put it at the end so you could see the difference between addition and subtraction. All right, last but not least, the division property. And I know I'm going to have to do this one twice, so I'm going to draw a little line. We'll save this space later on, and we'll do this again. 2x plus 6, leave a space, equals 12. Well, looking at all this, is there a number that we can divide everything by and actually get a nice answer? I think these are all even numbers, so couldn't we go through and divide everything here by 2? Let's try that. So same setup as before, group, group, divided by 2. Now I do have to say, this is completely okay. There's nothing wrong writing it this way. However, I think most people when you get to high school kind of consider this the baby way to write division. Instead of using that division sign, have you ever noticed that the division sign looks like a fraction with something in the numerator, something in the denominator, right? It kind of gives you a hint that a shortcut way to write division is as a fraction. The number that comes first takes the numerator spot. The number that comes second takes the denominator spot. So for pretty much every time from here on out, instead of writing this divided by sign, we're going to do division by writing this as a fraction. 2x plus 6 divided by 2. And I'm reading the fraction line as divided by. Same thing, 12 divided by 2. And then we're going to simplify. 12 divided by 2 is 6. Great. Well, in a similar way, where addition and subtraction were linked, where we just could drop the parentheses, multiplication and division are linked. If I had to distribute the 3 here, then I'm going to have to distribute the division with the 2. I need to divide by 2 and divide by 2. So 2 divided by 2 gets me 1, and the x just tags along. 6 divided by 2 gets me 3. And we get 1x plus 3 equals 6. And although that is, great as an answer, I'll tell you right now that generally we don't write this 1 that's in front of something, right? There's no reason to say, I'm going to multiply your money by 1. Well, if you have $10 and I multiply it by 1, you still have $10. If you have 1 times x, you just have x. So most people will write this as an answer as x plus 3 equals 6. Okay, now I did leave this blank. We will come back to that spot in a second, but we should probably go through and start solving equations here, since that's the point of today. So now that we know how to do the same operation to each side of an equation, we do need to actually remember how to solve equations. And I bet you've heard this phrase before. When you solve equations, it means we isolate the unknown variable. We take the variable and we get it alone. Now, there's no actual one way, correct way to solve an equation. There's an infinite number of ways to solve an equation. There is sometimes a fastest way, but there isn't one correct way, right? For example, what we could do here is we could take this x plus 3 equals 8, and I could say, I want to get x alone. So first, just for fun, I want to take x plus 3 and add 2 to this. And of course, whatever we do to one side, we do to the other side. So this, because it's addition, we can just say is x plus 5 equals 10. And then we look at this plus 5 and say, well, wait, x isn't alone. I know x isn't alone because there's still a number on the same side of the equal sign with the x. And this number is still adding to x. So we might think, well, wait, 5 is adding to x. Couldn't we go through and do the opposite of adding? Isn't that subtraction? And we could do something like this. I'm going to subtract 5 from each side. Drop the parentheses. 5 minus 5 is 0. 10 minus 5 is 5. And then you might remember, if you have x plus 0, if you have $10 and you add 0 more dollars, how much do you still have? Oh, you still have $10. If you have x and you add 0 to it, you still just have x. And we find that the value that makes the left side equal to the right is 5. Could you have seen that? Do you agree that 5 plus 3 equals 8? Some of these you can probably just see the answer, which is great. We're doing some easier ones today. What if I tried something else? What if I had this x plus 3 equals 8, and I said, ooh, x plus 3 equals 8, there's addition. Why don't I go ahead and subtract 6? That sounds fun. Well, 3 minus 6 is negative 3. This is 2. And then you might say, well, wait, that didn't help get x by itself. Now, instead of adding 3, it's being subtracted by 3. Maybe we'll do the opposite. Maybe instead of x minus 3, we'll do a plus 3 at the end. Okay, well, negative 3 plus 3 is 0. 2 plus 3 is 5. And we just talked about if you have x plus 0, we can just leave that as x equals 5. Oh, that's the same answer we got over here. Now, hopefully you're just like gnawing at your hands in frustration saying, well, this is so silly. Why would you ever solve an equation like this? There's got to be a faster way. Well, of course there is. This says x plus 3. So what we want to do is examine the equation and see just the side that has x and think about how are the numbers attached to x. In this case, 3 is attached to x by addition. And so we say, well, if 3 is attached by addition and I want that to go away, we need to do the opposite of 3. Sometimes we call it the inverse operation of adding 3. And the inverse operation of adding 3 is subtracting 3. Whatever we do to one side, we do to the other to keep our scale balanced. 3 minus 3 is 0. 8 minus 3 is 5. And of course, we don't need to write the 0. We just get x equals 5. All right. Let's move on to our next page. Although each method did get us the correct answer, x equals 5, was there one that was faster than another? Well, of course, the last one was the most efficient. And this enters the idea of the most efficient way to solve equations. The general idea for solving equations is that you need to undo everything that is attached or happening to your variable. Remember, x is known as our variable. To undo what's happening to x, you have to undo PEMDAS. And if you undo PEMDAS, then we work backwards. That means instead of PEMDAS, we actually do SADMEP. See how that's PEMDAS backwards? SADMEP. And this gives us an order of how to undo everything that attaches to x. So I have 3 steps on here. These are the only 3 steps you need for pretty much any linear equation ever. Let's go through it. Step 1. Use properties of expressions. That's usually our distributive property or combining like terms. Sometimes it's PEMDAS as well. On each side of the equal sign. That's it. We're not doing something to both sides. Just look at each side separately. Once you've done everything on each side and you can't simplify any further, move to step 2. This is where our algebra comes in, our properties of equations. First, you undo addition and subtraction. That's like the SA and SADMEP. So if there's a number adding to x, you subtract. If there's a number subtracting to x, you add. And of course, this is known as performing inverse operations. I mentioned that before. And what happened every time I added or subtracted the opposite here? Right? Add or subtract the opposite, add or subtract the opposite. Don't we get 0 every time? So when you undo addition and subtraction, you make 0. I know some of you will say, well, wait, do we have to write the 0? I know negative 3 plus 3 is 0. Couldn't I just have gone straight from here to the answer? And the answer is yes, you could have. There's nothing wrong with that. However, some students like to see the 0 at the beginning, and then they'll start forgetting it later on. Last but not least, the next part in SADMEP is the multiplication and division. And we're going to undo any numbers that are multiplying or dividing to x. We do this by performing inverse operations again, but this time when you multiply or divide, let's think, if you had something like 4x equals 8 and you wanted to divide, well, the opposite of multiplying by 4 is dividing by 4. So, x equals 2. But when I cross these off, a number divided by itself doesn't just vanish. 4 divided by 4 actually makes the number 1. So whenever you multiply or divide the opposite, or the inverse, you actually make the number 1. But we talked before that we don't really need to leave the number 1 in front of x. Isn't that what we did up here? Said there's a 1, but we don't need to write it. Yeah, that's another case of a number that we get to leave off. Now, today is the only day that I'm going to ask you to do this horizontal method for solving equations, right? And additionally, I am going to ask you to write the parentheses in each step. One last really weird request. Every equation down below, you're going to be able to solve without using the property of division. So for this page, I'm going to ask that you don't use any division. The only thing you can do to both sides are addition, subtraction, and multiplication. But you might be saying, well, wait, if I got this same equation, this 4x equals 8, how do I undo multiplying by 4? Well, I'm going to show you one other way. And it's clever. It's definitely a trick. Right? I said we'd come back to this. I left it a blank. So we're going to go through, and we're going to do 2x plus 6, leave a little gap, equals 12. And my question to you is there another way to divide by 2 besides writing divided by 2? I find it easy to put it with numbers. What can you do to 10 to get 5? Not subtraction, not division. Well, what if I asked you what is half of 10? I bet you all say half of 10 is 5. How do you write that math-wise? Well, of in math very commonly means multiply. So if I want to do half of something, it means times 1/2. Times 1/2. And now I'm going to go ahead and distribute this 1/2 to each side. Distributing to the left side, we do half of 2x, that's 1x. Half of positive 6, that's positive 3. Half of 12 is 6. Is that the same thing we got over here? I think so. Don't forget, instead of the 1x, you can drop the 1 because it's multiplying and come up with your answer. All right, this should give you enough to solve each equation on the next 9 problems here. Each of these equations require you to only do one thing to each side. So you're either going to add one number to both sides, subtract one number, or multiply one number to each side. After you get an answer, please plug or substitute the answer back into the original equation to make sure the left side equals the right. That's what we did up here. This method is known as back substitution. You find the answer and you substitute it back in to the original equation to make sure the left side equals the right. Many of these equations you'll be able to look at and say, oh, I know the answer already. I don't need to do the math. And you're half right. It is wonderful that you know the answer, but you do still need to do the math, because what we're doing today is building the foundation so that you have the ability to solve harder equations later on. I'm not asking you to do too many of them, just a few, and if you need the help, don't forget you can unpause the video, fast forward to the problem you're stuck on, and you'll be good to go. So please go ahead and try these 8 problems. Whenever you're ready, we will unpause, and we will be good to go. All right, at this point you should have finished all 8 of these problems, or you had questions, you're unpausing this to check your work. I'm going to go through all 8 of them. If some of them were easy, and you should probably watch this video on 2 times speed and move forward, just stopping on ones that you were curious about. So let's begin. First one, x plus 5 equals 8. Our whole goal is to isolate x, so we need to look at what is attached to x. So x plus 5, leaving a gap because we're doing this horizontal method, horizontal side-to-side method today. It looks like there's a 5 that's adding to x, so we're going to undo adding 5 by subtracting it. Of course, we have 8, so we should probably subtract 5. X plus 5 minus 5 becomes 0. 8 minus 5 is 3. We know we don't need to write the 0 though, and so we find our answer is x equals 3. We should probably back substitute to make sure we're right. If you substitute 3 in for x, is 3 plus 5 equal to 8? Hopefully you can see that yes, 3 plus 5 is 8. All right, number 2 is a little bit trickier. And the reason number 2 is trickier is because it looks like this is negative 2 that's attached to x by addition. What I would really suggest you do is whenever you have an x and a number that's adding or subtracting, make sure you write the x first. So what I'm going to use is called our commutative property, the ability, if we take these two terms, to rewrite them in any order that I want. I'm going to take this positive x and write it first, and then put the minus 2 and write it second. See what I did there? I just took these two and I switched their positions. The sign that's next to them has to stick with it. Now this is positive x minus 2. Whenever there's a positive first, we don't actually have to write the positive. It's just x minus 2. I'm going to leave myself a little gap because now we can see what's really happening is that there's a 2 attached to x with subtraction. How do we undo subtraction? Oh yeah, addition. We're going to add 2 to each side. X minus 2 plus 2 is x plus 0 equals 9, and so we end up with x equals 9. Moving on. Third one, I'm going to take my own advice, and I'm going to swap the order of the x and the 0.5. I'm going to put the positive x first, and the positive 0.5 second. Now we don't need to write both of those positives. I'm going to leave a little space by the 5. In particular, we don't need to write the positive that's in front of the x. And now we can see that 0.5 or 1/2 is adding to x. How do we undo addition? Well, we subtract the 0.5 from each side. 5 minus 0.5 is 4.5, and so we find that 4.5 equals x plus 0. Now, it makes some of you uncomfortable if I leave the x on the right side and circle this or box this, but there's nothing wrong with that. If it does make you happier, you perfectionist you can move the x to the left side and the 4.5 to the right, and you'll get the same answer. Okay, let's look at the fourth one. This one always trips people up because they're not quite sure how to read this fraction sign. So for this fourth problem, I'm going to read the fraction sign as one of our operations. We know the fraction isn't addition, subtraction, or multiplication. The fraction means division. This says x divided by 4 equals 2.5, and I left that gap again. How do we undo dividing by 4? Well, the answer is we multiply times 4. But this is where I see people make mistakes. People want to multiply by 4 in the denominator because they see where this divided by sign goes. What I'd really suggest you do is group in parentheses and do times 4. Group in parentheses times 4. Now, technically, if you're multiplying by 4, you're multiplying by 4 over 1. So actually, the 4 is on top of the fraction, which is where you want it to be. Multiplying by 4 on the top of a fraction undoes dividing by 4 on the bottom of the fraction. How does that work? Well, we have a times 4 and a divided by 4. These undo each other and turn into a 1, and we're just left with x. 4 times 2.5 can be intimidating, so let's do 2 times 2.5 first. $2.50 doubled is $5. Double that again, and you will find that 2.5 times 4 is 10. And we're set. Undo the division with multiplication. Our next one, 3x equals 12. Well, you might be tempted to say, oh, this is 3 times x, so I can divide by 3. And you're correct. Except, remember for today, we're not going to undo multiplication with division, strangely. Instead, what we're going to do is we're going to say 3 times x equals, and leave a little gap for 12. We'll put it like this. To undo 3. Well, let's see. Let's think back earlier. How did we undo this 2 that was over here? We multiplied by 1/2. This was 2 over 1. We used 1 over 2. And they canceled out. In fact, this always works with fractions. If we find one fraction, like this 3, and we write it as 3 over 1, the fraction that's going to undo 3 over 1 if you multiply will be the fraction, we'll group this in parentheses, 1 over 3. These flipped over fractions have a fancy name. Do you remember it? It starts with an R. These flipped over fractions are known as reciprocals. So I'll do the same thing with the 12. We'll do 1 over 3. It might help you to write this as 12 over 1. And let's see what happens. The left side we can cross-reduce. These become 1s. And if you multiply straight across, 1 times 1 is 1. And 1 times 1 is 1. And then we have an x. Equals, on the right side, we can cross-reduce. 3 divided by 3 is 1. 12 divided by 3 is 4. And then we can multiply straight across. 1 times 4 is 4. 1 times 1 is 1. But we don't really need to write numbers over 1. That's just silly. 1 over 1x is just 1x. 4 over 1 is just 4. And actually, we've also learned if you have 1 multiplying, you can just keep that as x. And we're set. Easy to check. Is 3 times 4 equal to 12? Sure it is. Moving on. Now you might think, well, this was silly. I would never want to multiply by 1/3 when I could just divide by 3. But what happens if you get into a situation like this guy, where you have 2/3 that's multiplying by x, and you need to undo the 2/3? Well, if you follow the same pattern we did before, we had a 3 over 1, so I used a 1 over 3. If I have a 2 over 3, I'm going to undo that with its reciprocal, 3 over 2. And I'll do the same thing with 8. 3 over 2. We'll probably want 8 to be over 1. And let's see what happens. We can cross-reduce the 2's, cross-reduce the 3's. 1 times 1 is 1. 1 times 1 is 1. X. On the right side, we can cross-reduce the 2 and the 8. 2 divided by 2 is 1. 8 divided by 2 is 4. And then multiply straight across. 3 times 4 is 12. 1 times 1 is 1. We should be able to see now that this 1 over 1 we don't need to write in front of the x, and 12 over 1 is 12. 2 to go. Negative 5 times x equals 2. All right, well, let's just go ahead and continue that same thing. We did this before. We have negative 5 that's multiplying by x. I'm going to leave a little space. We'll write that as over 1 so that we can easily see the reciprocal. The reciprocal of negative 5 over 1 is 1 over, and the negative stays with it, 1 over negative 5. On the right side, we need to multiply this by by 1 over negative 5. Maybe it helps to put this as 2 over 1. Well, on this left side, negative 5, let's just multiply straight across. Let's pretend we don't know we can cross reduce. 1 times negative 5 is negative 5. Negative 5 times 1 is negative 5. On the right side, straight across, 1 times 2 is 2. Negative 5 times 1 is negative 5. Well, simplifying the left side, any number divided by itself, we should know that. Any number divided by itself is always 1. On the right side, 2 doesn't divide nicely by negative 5. However, this is algebra, which is cool. We don't actually have to divide this. This is a fraction. It is the fraction 2 over 5. There is a negative. It's pretty common with fractions, though, that you don't leave the negative in the denominator. Most people will move it just next to the fraction line. Could you keep it here? Sure, there's nothing wrong with that. Well, finishing this off then, we know we don't need the 1 in front of the x, so we get x equals negative 2/5. Now, someone might say, well, wait, negative 2/5, I don't like that fraction. That scares me. I want a decimal. Can we do this as a decimal? Sure, we would just do negative 2 divided by 5, and you would find that this is negative 0.4, or negative 4/10. Any of these answers are fine. I tend to like fractions more than decimals because I think they're easier, but it is totally okay to do the decimal. All right, problem 8. Negative x equals 7. Well, what's happening here? You might say, oh, is 0 subtracting by x? Well, kind of. But actually, I would argue that there's multiplication at play here. In particular, we learned, and we just did this, that if you have a 1 multiplying, you don't need to write it. What if you had a negative 1 multiplying? Well, you wouldn't need the 1, but you'd leave the negative. So one thing we're really going to have to start to recognize in algebra is if you have a negative attached to x, what that really means is you have negative 1 multiplying by x. And I'll leave a little gap for the 7. So how do we undo negative 1 if it's multiplying? You might be tempted to say divide, but remember we can't divide today. Not yet. You will soon. Promise. So I think that means we need to multiply by the reciprocal. This is negative 1 over 1. Let's flip it. We'll multiply by 1 over negative 1. Same thing over here. 1 over negative 1. If you multiply straight across here, you'll get negative 1 divided by negative 1 times x. On the right side, you'll get 7 divided by negative 1. Anything divided by itself is 1. 7 divided by negative 1, well, you could keep this as a fraction, but I think unlike this previous problem, 7 divides very nicely by negative 1. 7 divided by negative 1 is negative 7. And then we finish this off. We know we don't need to write the 1. It's technically known as the identity property. And we're done. All right, so hopefully you're feeling at least a little confident on these one-step equations. We only had to do one thing. I did it in red every time to both sides. We did some fractions, some decimals, some positives, some negatives. Well, our last part for today, since we just reviewed one-step equations, which as a reminder is 6th grade, now we're going to review two-step equations. Two-step equations is just using two properties of equations. You're going to add or subtract one thing to both sides, and then you're going to multiply or divide. And yes, I said divide because at this point, instead of multiplying 2x by 6 by the reciprocal, I always have to sound that out, of 2, right? If this is 2 over 1, the reciprocal is 1 over 2. You may now actually go ahead and divide by 2. 2 is multiplying, so we can divide both sides by 2. Okay. We're still going to use that horizontal method side to side until tomorrow. And yeah, we're going to see what you guys can do. I do really like, by the way, to write in those invisible ones, kind of like what we saw in problem 8. I put in this invisible 1 in front, or maybe on this third problem down below, 5 equals negative 1 times x. Anytime you see those invisible ones, oh, here's another one, probably a good idea to put those in. So there's 6 problems here to finish us off. Your goal is to do these on your own. Don't forget we're following SADMAP, and I'll write this over here. It means your very first move is to undo addition and subtraction, then undo multiplication and division, and actually we won't tackle either of these for the rest of this semester. So, good luck. If you get stuck, you can unpause and fast forward to that, and I'm excited to see your success. Ready, set, go. All right. You're back, which means you're ready to check your work. If any of these were super easy for you, please feel free to skim through to the end. I'm going to go ahead and show how I would do this. 2x plus 3, leaving a space, equals negative 5. We want to undo the addition and subtraction first. So if we look at the side with x, there are 2 numbers on that side. There's a 3 and a 2. The 3 is attached to x with addition. The 2 is attached to x with multiplication. Do we undo addition or multiplication first? Well, we undo addition first because we work from top to bottom. So I'm going to undo the adding 3 first. Opposite of adding 3, subtracting 3. This becomes 2x plus 0 equals negative 8. We know we don't need the 0. All right, are we done? Well, no, there's still a number on the same side as x, the 2, and the 2 is multiplying by x. So how do we undo multiplication? Well, now you are free to use division, so we're going to go ahead and divide both sides by 2. Don't forget to group in parentheses, though. So we're going to divide both sides by 2. We distribute the 2 inside. 2 divided by 2 is 1x. Negative 8 divided by 2 is negative 4. So x equals negative 4. Nice. Let's try a couple more. Problem 2 says x divided by 2 minus 3 equals 5. All right, so we have x divided by 2 minus 3 equals 5. What do we undo first? I should have left myself more space. Nope, more space. There we go. Well, we have, if we're thinking about PEMDAS or SADMAP when we undo a problem, we isolate x, we undo addition and subtraction first, so which on this side is adding or subtracting to x? That's the 3. So I'll need to add 3, the opposite, the inverse, on each side. This becomes x divided by 2 plus 0 equals 8, or just x divided by 2 equals 8. What now? Well, now we undo dividing by 2, and the way we undo dividing by 2 is we multiply by 2. Multiply by 2. Multiplying by 2 undoes dividing by 2. It makes a 1, and it leaves us with x equals 16. We should probably check that. What's 16 divided by 2? Well, 16 divided by 2 is 8. What is 8 minus 3? Oh, that's 5. We've done it well. Third one. 5 equals negative 1 times x plus 2. What do we undo first? SADMAP will tell us. That's very kind of it. Addition and subtraction. Well, looking on the right side, I see a 2 that's adding and a negative 1 that's multiplying. We undo addition and subtraction. We're undoing the 2 first. So we have our 5, and a bit of a space, negative 1x plus 2, and we're going to undo that adding 2 by subtracting by 2. 5 minus 2 is 3. This becomes negative 1x plus 0. So we find that 3 is equal to negative 1 times x. All right, let's finish this off. Negative 1 is multiplying times x. Now we're allowed to use division. This does throw some people off. They think, oh, we're multiplying by negative 1, so do I divide by positive 1? Well, if you divide by positive 1, a negative divided by a positive stays a negative, and you won't have gotten rid of the negative in front of the x. The opposite, or the inverse that we're doing here, is the inverse of multiplication, which is division. We're doing the inverse of multiplying by negative 1, which is dividing by negative 1. Group each side, divide. A number divided by itself is 1. And so this leaves us on the right side with 1x. On the left side, 3 divided by negative 1, a positive divided by a negative is a negative. Oh, and wait, if we just have a 1 multiplying, we don't need to write that. We have our final answer. X is equal to negative 3. All right. 107 equals 3 minus 1x. Well, I don't like this. I always like to write my term with x first. So I'm going to reorganize this. I'm going to say 107 equals negative 1 times x comes first. And then what type of 3 goes at the end? Is this 3 positive or negative? Looking out front, there's no sign, which tells us the 3 is positive. All right, there are two numbers attached to x. 3 is adding, negative 1's multiplying. So let's leave a little space and think about what we need to undo. I think we need to undo adding 3 by subtracting 3. This gives us negative 1x plus 0, and on the left side equals 104. Or 104 equals negative 1 times x. What's the opposite of multiplying by negative 1? We just did this. It's dividing by negative 1. This makes a positive, negative by a negative. That's what we want. We want a positive 1x. On the left side, a positive divided by a negative is a negative. And so my final answer, if you want to write the x on the left side, you can. X equals negative 104. All right, 2 to go. Fifth one. 1/3 x minus 5 equals 7. Well, I see two things happening to x. The 5 is subtracting from x. The 1/3 is multiplying. We know by now that SADMAP tells us to undo addition and subtraction first. So we'll undo subtracting 5 by adding 5. This gives us 1/3 times x plus 0 equals 7 plus 5, 12, or 1/3 times x equals 12. Now here's where things get weird. You might say, ooh, I want to, and I'll use a different color, I would like to divide this by 1/3. But then you're dividing by a fraction. And dividing by fractions I find really throws people off. So instead, let's use the trick that we learned before. We do want to get rid of the 1/3, but instead of dividing, the trick with fractions is we can multiply by another fraction. What fraction? Well, the reciprocal of 1/3, which is 3 over 1. Same thing with the 12. I'm going to multiply by 3 over 1. Let's maybe put that 12 over 1 too. When we multiply reciprocals, they will always cross-reduce, and they will always give us 1 over 1x. On the right side, we can just multiply straight across. 12 times 3 is 36 over 1. In fact, dropping all those extra 1's, don't we just get x equals 36? And that's pretty easy. Multiplying by the reciprocal of 1/3 is 3 over 1. That's just multiplying by 3. Last one. Negative 5/3 x plus 1 equals 26. Well, similar idea. Negative 5/3 x plus 1, leaving a space, equals 26. We need to undo the adding 1 by subtracting 1. Leaves us with negative 5/3 x plus 0 equals 25. Or that's just negative 5/3 times x equals 25. From here, we need to undo the negative 5/3, and I'm not going to divide, even though you can. If you want to go that way, that's okay. I'm going to use the reciprocal. The reciprocal is the flipped over version of the fraction, 3 over 5. The negative's right in the middle, so we'll keep it right in the middle. Over here, we have negative 3/5. Notice I wrote the negative on the 3. We don't need to do that. We can just leave it on the fraction. It's up to you. I will write the 25 over 1, though. Okay, let's reduce these. 3 and 3 become 1's. 5 and 5 become 1's. Negative times a negative gives us a positive. Positive 1 over 1x. On the right side, more reducing. 5 divided by 5 is 1. 25 divided by 5 is 5. We multiply straight across. This fraction is positive. This is negative. We know when we do a positive times a negative, we get a negative. 5 times 3 is 15. 1 times 1 is 1. Cleaning up those superfluous, those extra 1's, we get x equals negative 15. Hopefully you're feeling pretty confident on these 1 and 2 step equations from today. SADMAP is really going to be your savior, so make sure that you follow the instructions, addition and subtraction first, then multiplication and division. You do have your first independent practice tonight, your first homework. It's between 6 and 10 problems. Make sure you come prepared. You can use your independent practice and your notes on your knowledge check on your quiz next class, and we just want you to be successful. So thank you for tuning in. If I made any mistakes or you need any clarifications, feel free to post in the comments. Have a wonderful day.